and it's really focusing on the ease of application deployment using the cloud. I know historically it's been difficult buying software infrastructure. The processes required to purchase servers, to size them, to scale them, to have them delivered to your data center, to have someone plug them into the wall and install them, your operational team to configure them. The goal around Cloud Foundry is to abstract as much of that away as possible so that you can just easily deploy your application in a simple and repeatable way with it being managed as the platform itself. So Cloud Foundry is what we call a PaaS, Platform as a Service. What does that mean? It means it lands in the Platform as a Service column. It's that easy. Next. But really what it's saying is this service will manage everything that is gray in that side. So software as a service might be something that you purchase, you go online to use it, you don't really have to manage that at all, your company doesn't have to manage it. From top down, they're kind of supporting everything, the databases, the infrastructure, the software itself, the enhancements. As you move over as a platform, really your company starts managing the applications and the data, but the platform will manage everything else, everything from the runtime down. Infrastructure as a service, that's when we start getting into things like GCP, AWS, Azure, things like that, where you're owning more and more of it, but they're kind of managing the actual physical underlying infrastructure. And finally, packaged software, which is really saying, here's the software, turn it on, figure it out, manage it yourself. So PCF kind of lands in the middle there. It's really looking into saying like you can use the cloud provider of your choice. We are a platform that will sit on top of that, and then you can interact with us in a standard, normalized way, and we'll figure out how to do everything underneath it. So there's some philosophies or some terms I want to get going, make sure we understand that. So we're talking about architecture and organization, orgs and spaces. So organization, orgs in Cloud Foundry are your logically separated tenants. So the idea is that I can have my own org, you can have your org, different companies can have their own org if you're on a public cloud. If you're on your private cloud, you might want to separate this out by applications or by environments, whatever makes sense, by department sections, whatever. It's totally up to you and your company and yourself to figure out how to separate them. Within orgs are spaces. So these are again used to separate organizations. And applications and services are now scoped to a space. So I might have two orgs. One is my production org and one is my test org. I might have different spaces underneath it. Maybe my test org has a dev, a staging, an acceptance environment, an load and performance environment, and then each of those might have their own services bound to them based on the different needs or the different organization there. It's up to you to separate how you do this. It's important to note this is all logical separations. If you're all in the same Cloud Foundry foundation, it's all shared infrastructure underneath it. So it's not like an org has a virtualized, a totally physical separation based on the service being deployed to. It's all shared under that. We look into roles and permissions. These are how the people can interact with your Cloud Foundry foundation. So you can see here multiple organizations. You can have multiple organizations that each have multiple spaces, and each of those have multiple applications. So there's some platform level roles. These are your admins. These are your global auditors. Anything with auditor in the name is a read-only access. So they can kind of log in. They can see what quota, how much space you're using, how much CPU processing, things like that. Good for billing, operations, things like that. Your admins can do anything. They can add or remove services from the marketplace. They can deploy applications. Org managers manage the org, more around the sense of quotas and people. And then when you get to the bottom, your space developer, that's the role that you really want to deploy applications. So space developer and admin are the only two roles that can actually deploy applications. The rest are more managerial support roles. As I mentioned earlier, you can set quotas in your space. This is good for your platform team or your Cloud Foundry team to kind of configure how much a particular application can consume when it comes to the shared resources that are shared all under the hood. So you have to set up an org. You don't necessarily have to set up in a space, but you can if you'd like to. So maybe there's a particular reason why you would want this space to be sized larger than another space. As you can see here, these are all the configuration elements you can make here. Your total memory, memory per application instances, number of routes, number of service instance. If this space is allowed to purchase or use paid services or only the free tiers. So we'll talk about build packs. So build packs are the framework and runtime environment that your application will run in. So for example, if I'm running a Java app, app and I want to run it in the cloud, it'll likely use a Java build pack that has Java installed. Right? That way it can actually start up and run. If I'm using a Node build pack, it'll have Node and all of its dependencies installed there as well. So what happens is when you stage your app, Cloud Foundry uses some magic logic to figure out which one works, what is the build pack I want to run my application in. It'll run that on staging and then build a dropper, which will be ultimately deployed. We'll talk about that in a little bit. They are ordered, right? So like it'll go through this hierarchy saying, is this one next, is this one next? So you could have the lower tier Java one if you're preferring the default to be this Java version, not this Java version. You can also explicitly say what these are while deploying, so that if my app requires Java 11 and it may not be the #1 Java hit, it'll know which one to grab. Ultimately, if it can't identify the build pack to use, it just fails deployment, and it's up to you to kind of figure it out. So we'll talk about services here. So CF exposes, Cloud Foundry exposes this Open Service Broker API. This is a great API that allows different entities, different companies, or yourself to create custom services that you can now interact in the marketplace with. So here's like a snapshot of a bunch that's offering on Pivotal.io. So as you can see, these things go from databases to application monitoring to anything that you might want to bind. There's logic binders to it, like autoscaler, things like that. But using the Open Service Broker API, you can configure these yourselves. So like if you're an infrastructure admin at a company and you want to offer an automated way of spooling up MS SQL instances, you can configure your own Open Service Broker and get it so that it can be a one-click deployment, one-click teardown, things like that. What this really means is that it's extensible, which is why you get a strong marketplace volume. So Cloud Foundry offers high resiliency for your applications. As it starts each application process, it's constantly monitoring these processes for failures. If it detects that a process is no longer healthy, either through report checking or process checking, it'll automatically tear it down and spool up a new instance. So if you're running an application in production and for some reason it crashes, Cloud Foundry will detect it and then redeploy it. Beyond that, you can define availability zones for your Cloud Foundry instance. A lot of good reasons would be across different data centers, things like that, just using a single platform. And what that means is that you can have different versions of different instances running different availability zones. Again, if your cloud provider has a critical problem, it'll fail it and then move it over to the other side. Your app really never goes down. There's some baked-in features there. Of course, it expects that you are deploying more than one instance of your application, which I trust you're doing in production, again, as your step one fail-safe. So it supports this idea of zero downtime deployments. It's also known as blue-green deployments. And this idea here is how do we deploy an application without actually introducing any type of outage? Sometimes you take an application, you deploy it, it takes 20 minutes to start. Well, that means that it's 20 minutes of outage on your time. A lot of companies count that against you. If you're looking for, what's your uptime per year, you're looking at 4 nines, 5 nines, 99.999. How does this impact it? So Cloud Foundry has a process that you can leverage that will give you a zero downtime deployment. So why don't we walk through that? So let's say I have an application here. It's running on application URL.cfapps.io. This is this product called the CF router. All the incoming network traffic routes to the router. It uses its database tables and its understanding of the infrastructure to know which application to actually route the request to. So what's happening here is in production, my requests are coming into the router. It's being forwarded onto my application, which is able to service it however it needs to be. But let's say I want to deploy a new version. So what I'll do is I can deploy a new version of my application in a separate container, right? And I'll wait for that to become healthy. So I'll wait for it to start up. Well, Cloud Foundry, what we can do is then assign it a new route. Same route, but I just put -new on it. When it becomes healthy, I can actually run smoke tests here, right? It's a live living app. I can run smoke tests. I can make sure it's working the way I want. When I'm confident, or my automated process is confident, what it'll do is it'll route the existing URL to it. So now what I have is I have the CF router load balancing between my two instances in a round-robin fashion. So again, I'm still not down, I'm still sending traffic, but half of my transactions are going to my new service and half are going to my old service. At that point in time, we can tear down the old route from the old instance. 100% of my traffic now is now running to my new instance. From there, I can tear down the old temporary route, and then now I have a situation where my app is I can tear down the old app now. And now I have a situation where it is incurring transactions. So this is like a simple blue-green model with some smoke tests. I want to demo some of this later. There's a CF plugin for the command line that will do this for us, and we can see the steps as it takes as it walks through that.
Paul, quick question.
Sure.
If you're load balancing it, how do you ensure like state efficiency?
So like under the hood, that can be very complicated, especially if your deployment requires on database or schema changes. It can become complicated. So it does, for your simple patch and bug releases, this is a straightforward, easy way to manage it. If you're looking at a more complicated release, you're going to need more thought process around this. And you might even need to kind of come up and do database migrations as part of this step, right? I might need to maybe spool up a new database, migrate some data into it, validate it, and then do the cut over, right? Especially if I have a schema change. All right, cloud native development. So a lot of the ability to run this really depends on how we manage our code and how we actually deploy that. So this cloud native development concepts come out, and they really lead to like what are some of the best practices around development. So I'm sure you guys have heard of the 12-factor app. This idea that if you follow these 12 practices, these are kind of brought together from some of the team members at Heroku and other parts of the industry, saying like if you're doing these steps kind of lead to the easiest way to manage and upgrade our code without kind of incurring like technical debt around our infrastructure and whatnot. So we can kind of talk through these a little bit. So the first one is code base. The idea is that one code base is tracked in revision control. So first of all, use revision control. Don't share files around or zip files or whatever monstrosities you guys can come up with. Use a central code repo. I don't care what it is. But what you really want to do is track it through one repo. And that repository now leads to multiple versions of your applications that you can tie back to it. This is our version 1, it's tied to this code, version 2. And this repo is a single deployable that's tracked through. So if you have a single app, you're tracking a single repo, it's easy to build a single artifact and it's easy to track that. As soon as your infrastructure is being more complicated where you're deploying multiple apps, split those into different repos. Because now you've built a distributed system and an application, and those should be tracked independently. Dependencies. Declare your dependencies explicitly. The way we used to do it is you deploy to an application server that had all your dependencies already installed. You would just assume they were there. Really what you're doing is you reduce your portability of your software by doing this from either different clouds or from different application environments. So a lot of the ways we do this now is we kind of package it as a fat jar or a fat deployment, which is the application plus all of its dependencies. And this means that it's more manageable and easier to move around. Store your configuration in the environment. Configuration here is anything that could change between environments. Maybe you use a different URL in production than in your lower environment. Maybe you have a different thread pool size in prod than your lower environment. These are all configurations and they should be stored in the environment. And the reason for that is I should be able to easily take my deployment, move it to another cloud where it can use its specific configurations. If those configurations need to change, it's easy to actually expose them and change them. It's not hard-coded in your code somewhere, which leads to problems. We'll have a Microsoft update, excuse me. All right, so this idea of backend services, treat them services as attached resources. It is unlikely that your application does not depend on some external application, whether that be another API or another piece of software or a database or Redis or whatever it may be. And the idea is to treat that as an attached resource. And really what this is getting down to is treat it as a URL. How do I expose this as a URL that could be migrated, changed, and updated? Right? So if I'm connecting to Redis, I have a Redis URL that's probably this long, it has username and password in it, whatever. But that means that if that was to migrate to a different platform or change, I'm still communicating it the same way. And this is how you kind of decouple yourself as your application from your dependent services. Separate your build, release, and run steps. These are different considerations. Your build step needs to set up the world, right? It needs to download your application, your source code, it needs to compile it, it needs to put your dependencies in, and then it needs to build a deployable artifact. That is a very different step than your run step. Because what happens is your run step is really, I need to turn this thing on, and you likely need to turn it on fast, right? If your application goes down in production and you need to restart it, you don't want to have to rebuild and download your jars for your dependencies. So the idea here is like treat those as independent steps so they can be run independently and you're going to have less pain in the future. Processes. Execute your app on one or more stateless processes. The key word here is stateless. If your application needs to record its state, for example, if you have a 3-part sign-up process and you have to remember each step, it's likely that as you're in a cloud environment, your instance could be torn down, it could be recreated. You could be load balanced across many different versions of your applications. So if you require a prior state, it's going to be hard to actually manage that. So the encouragement here is to manage as stateless processes, store them off in your external service where it can be pulled in later. So again, if I have a 3-part sign-up process, maybe the first one you type in your name, I'll take that, I'll store it in my database or in Redis so that when you submit on the next page, my app can pick it up, remember the state, and then continue. It's not stored in memory, it's not stored in the in-memory session, things like that. Port binding, export services being port binding. This is really the inverse, manipulate your server. Like you're kind of doing something wrong fundamentally. So you don't want to have to do that, you want to have this thing scripted and kind of set up in a way we don't have to. But more or less, don't run it in your container as your production. These are separate scripts that need to be run independently on their own. So if you follow this, all your development woes go away and we're all happy, right? I wish it was that true. There is no silver bullet. But let's talk about a little bit of the anti-patterns that we pulled out here, right? First of all, relying on the local file system. When you're in the cloud, you're being built up and torn down all the time, so you can't trust the local file system. Building apps that scale up instead of out, right? Don't think about how do I store more in my one JVM. I might have a lot of them, and I should manage it and encourage my software to be built that way. Manually change the code in the server. Oh my God, if you're doing this, we need to rewind a lot of steps. But you shouldn't have to do that, right? Use your source control, use your automatic CI/CD pipelines, deploy and build in a predictable, repeatable way so that you don't have to think about this, right? As developers, our job isn't to build software, it's to write good software. These are processes that we should be able to automate and move off to the side. Don't do manual builds, kind of just talked about that. Hard-coded configuration, you see this in a lot of like old applications where it's hard-coded in the code, you have to rebuild a new version. Expose those to the configs and keep your config on your environment. So that way you don't have to manage it yourself. And then the monolithic app, we're just going to leave it at that. There's a lot of buzz around monolithic apps. There's pros and cons around them. There's complexity and simplicity around microservices. But in a cloud environment, it really is trying to lend itself towards a microservice architecture because of the ease of independently scalable and deployable artifacts. All right, so I real quick want to walk through some of the Cloud Foundry UI. Real simple, I want to just kind of point out the UI itself, a little bit where things are. I'm more of a command line kind of person, so I'm going to try and do most of my work through the command line as we get to later on, but I wanted you guys to see the parallels between the UI and then the command line. So here's a dashboard view. As soon as you log in, this is where you land. It's really just showing the org managers, the different orgs I'm a part of. I'm part of the Cloud Training.io org, so it's the only one you see there. But I can click a new org, I can create my new org right here on the screen, because that's the hierarchy. Orgs are like the largest group of your configurations. From there, I can click into my org view, and I can see my quota here at the top. So I have 25 day quota. I can see my building statements, so those of you who are in infrastructure and like to build the rest of your company, that's your favorite button probably. And then the different spaces here, and I can create spaces. On the left-hand side, I can see some more information. So first of all, the number of spaces I have, the domains that I'm able to bind to. So like maybe we have a custom one for my company, a separate one for your company. That's where you can configure them and have them here up front. The other members of your org can be seen here, and on that page you can add or remove people and set the roles. And then finally there's the settings tab, which kind of gives you the customizations. As we dive in deeper, you can now see your spaces. So my one org has many spaces here. I'm sorry, I have one space here, it's called development, and when I dive in a layer here, these are the applications that I have running in my space. And then as well as the routes that are bound to them on the right hand side. So I can see their status, if they're up or down, these are all turned off and haven't been pushed in 4 months. Number of instances and the routes, right? Again, I'm diving in deeper so I can see who's in my space, the other developers, the other admins. I'm seeing on the left there's the service tab, which is all the services that are provisioned to my space. Remember, services are at a space discretion, and then again the routes that have been that are currently reserved for my space. Routes can only be bound to one space. So if I stole, hello world.cfapps.io, well guess what, I get it. and no one else can have it unless I remove it. Cool. And then finally, you can dive in your application, and here you can kind of interact with the application yourself. So on the left-hand side, going down, you have all your tabs. These allow you to view the logs, view the configuration settings, edit these things, right? If you wanted to change the config, things like that, which again is a bad practice for 12 factor, but it can be done, especially if your project is dead and you need to fix it fast. And then like some history on who pushed it, what were the states of it, things like that. If you go back out to the org view, you go to the marketplace, that's going to show the marketplace offerings that your team has installed on your cloud, Foundry Foundation. You don't necessarily have to have everything. You can customize the install, you can remove them, you can hide them, you can create your own, again, like we said. So this is just a view where you can kind of manage them and set the configs around it. All right, talk about the CLI, my favorite. All right, so we'll have a little bit of topics here because it's actually my favorite, so I made it the busiest part of it, right? So we're going to know a little bit about the overview, some basic commands, how to authenticate, and then how do you deploy an app using the CLI. So let's get going. The Cloud Foundry CLI overview. So it uses the CF REST endpoints to interact with Cloud Foundry. It's very simple. If you turn on the CF trace environment variable on your computer, you can see this thing talk back and forth with Cloud Foundry. There's a lot of chatter there, so it's actually quite interesting to watch, and maybe we'll do that later. Anything you do in the UI can be done over the CLI. So again, automation is always in the back of the mind with this product. How do we make it so that you can write customized scripts so that you don't necessarily have to walk through everything yourself? And then finally, you can extend the CF CLI via plugins, which allow you to run custom processes through the CLI, which allow you to have custom or different interactions with those REST endpoints. Cool. So if I run CF, this is the command, CF-H, I get a nice, beautiful screen on how to do it. Here you can see there's just a small group of sections here. You have your application life cycles, so how do I deploy an app, how do I delete an app, how do I restart or restage an app. You have your service life cycles, how do I create and bind services, unbind them, or delete services. Route management, again, binding to routes, creating routes in my CF, or binding them to applications, unbinding them, etc. Space and org management. Again, creating spaces, deleting spaces, and then also administrative tasks. So how do I add people, how do I remove people, how do I change people's roles? That was the admin role. So right here, these are the custom plugins. If you run CF repo plugins, it allows you to see all of the currently community supported plugins that are part of the default repo. If you want to install one, you just run CF install plugin. And then I wanted to highlight here a blue-green deployment repo, one that came out. Plugin that's available right there. So CF Blue-Green Deploy. We will use that later. I want to show it as part of my demo to get you guys a sense of how to do that. So step one with any modern day piece of software is you must authenticate with it before you can utilize it. So you can do that here with CF Login. As you can see here, it's very simple. CF Login, username, password, and the API you want to go against. So in this case, we're running against the run.pivotal one, which is hosted on through Pivotal Stack. If you have a custom one, you can run it to yourself. You don't necessarily have to use that. And then if you'd like to log in straight to an order space, you can define that here. If you only have one order space, the way I do, it's going to just automatically drop us into that. If you don't specify that, it'll ask you, hey, you're part of 10 orgs, which one did you mean? Hey, you're part of 10 spaces, which one did you mean? Okay, I got you. Skip SSL validation if you don't want to run SSL validation, which sounds like the safest thing on the planet you could do, etc. So we'll be showing that today. Going back to Ansi's tweet, CF push is the $1 million line. That's the one that takes your application binary from your local machine, pushes it to the cloud, kicks off the staging process, gets that all stored and turns it on. So this one line is intended to be the easy thing that makes every developer's life easy because it's just one line and you have an application. So here's an example, CF push app name -p, and then app directory. Here's an example using the Spring Pet Clinic jar. You can define the path to it, the path to your build pack. We'll talk about what a build pack is. And then there's a lot of configuration on this thing, no start, random route, things like that. But let's talk about like some of these deployment steps. So what is Cloud Foundry actually doing when you're running that CF push command? The first three steps, can you guys even see that? right? You don't know how to zoom in, so we'll just rock with it. So the first 3 steps here is really uploading the configuration that you define into the cloud controller database, and really that's storing the meta information about your app. So like, what is the app's name? What space did you deploy it to? How many instances did you request to deploy? What's the route? What's the resource sizes? Things like that. Once it gets the initial entries completed, it'll then upload the bits of the application, which gets stored in the blob store. So this would be like your jar if you're deploying a Java app, things like that. And that will get stored and then saved for later. Finally, it starts the staging process. And that's really how it takes the binary bits of your application and then figure out which build pack it is. Once it creates a build, finds the build pack, it'll create this thing called a droplet. This droplet is an executable version of your application. This is really tying back to those 12-factor rules, really saying that this is the run cycle. If I run this command and kick off this thing, I have your application. And it's really trying to optimize the startup time, so we're not having to rebuild this thing or revariant this thing to drop to build packs. That gets stored in the blob store as well, again for fast regrab. And then finally it takes that and starts it up, right? It's now executing its monitoring on it, making sure the process is alive. Once it becomes healthy and is considered started up, it'll bind the route to it and expose it over through the CF router. Well, it happens in that one CF thing, you can see the logs chit-chat like crazy, and then all of a sudden there's an application running. So if you have problems with your CF push, as in it fails, here's some quick 101 on what to start looking at. First of all, check your quotas. It often, if you're doing a blue-green deployment, takes up twice the amount of memory as your app usually does, because you're running 2 instances of it or more. So be warned that if you only have 2 gigs reserved and your app uses 2 gigs, you're probably going to fail if you're doing a blue-green deploy. Check on stuff like that, work with your admins if you need to extend that larger. Permission failure, again, if you're not the right person who can push apps, admin and space developer are the only 2 roles that can do it for a space, so be aware. We haven't talked about manifests, but we will. But if there's an issue in the configuration that you defined, or your build pack is unable to be found, or is something faulty with that, will cause it. Timeouts and unaffected memory use, right? That's going back against the quota. If you're having issues, let's check the logs, right? But I just talked about how logs are bad and hard to look at, so let's talk about how to do that in a cloud environment. So there's a feature called CF logs. So CF logs your app name. What that'll do is that'll stream the output of your container straight into your CLI. So you can just watch the kind of logs go through there. It's important to note that CF has a very small buffer when it comes to the log sizes. If you run CF logs -- recent, you'll be able to see everything that's in the buffer. It's normally not that long, but if you wanted a quick snapshot in the last few transactions, you can see what's going on there. But again, if you need long-term logging support, which we all generally do, the recommendation is use like a Splunk or an Elk, some kind of a long-term log support product. Or write your own. If we're in the cloud, we can do anything. We're developers. Cool. So there's this CF map route. We talked a little bit about blue-green deployment. This would be the manual command line you could run to build your own route and bind it to your application. So you say CF map route, my app name, the hosted domain. So if you're using the pivotal Cloud Foundry offering, it would be cfapps.io. If you're using like a custom one, you might have one bound to your application. You define it there, and then that map to route. So my new application.cf routes, cfapps.io. There's the example right there. So then I can have multiple. There's no limit to the number of routes unless you have a quota on it. You can bind to a particular application. So a lot of applications will have 2, one for the public, one for the internal apps, things like that, depending on your utilization. But you can have many. Through the CLI, you can configure your environment variables, right? So we're talking about how do we move our configuration to the environment. You can use cfenv to see your currently deployed configurations. You can set env, defining the variable name and the value like to set there. You can unset it, which just removes it. These get applied to your application through the VCAP services and VCAP application part of the deployment scripts. Services are really reserved for your Cloud Foundry service configuration, which get injected into your application. So if you were connecting to a database, like a MySQL database, you'll see it in there. Otherwise, you can set by your own configurations in there as well. These can get set by the user. They can be set by your CI/CD pipeline. These are all command line interactions. So I would recommend going with an automated repeatable thing like a CI/CD pipeline. It can get really complicated doing a CF push dash I for the number of instances, dash N for the number of this, dash M for the amount of memory, dash R for my route. So that command can get really long. So they offer this thing called manifest.yaml. This is a configuration file that you can use that defines the configuration of your artifact. So this is something you can check into your CI/CD, check out when you're doing your deployment, revision it there, follow it there. Good practices across the board. There's consistency, reproducible. I can just do cf push-f manifest now. Simplifies the command a little bit, but allows us to really codify the environment configuration that we're looking for in Cloud Foundry. So here's an example one. My Spring Pet Clinic Chicago Cloud Conference application. I'm asking that I get 2 gig, 2048 megs of RAM, of memory. I have 2 instances for redundancy. In case one goes down, I have the other one. The path is for deployments. It's running on my local. I'm doing a Maven build, so it gets dropped into the target directory. I'm binding this route to it, Pet Clinic CCC CFF.io. I'm telling it, give it 60 seconds to start up or fail it. That's just a nice little thing in case I'm having deployment issues or for some reason Cloud Foundry's under stress. Maybe I don't want to further stress it by having a longer timeout. And then here I'm saying, hey, let's set my root logging level to debug. So I've configured it here. All right, let's do some coding. Really some deploying, right? So I want to show this first Spring Pet Clinic. It's a kind of an off-the-shelf tool. It's managed by the Spring community, but really it's a sample application that they built to showcase the Spring stack. It dates back all the way to the early versions of Spring, where they kind of use it as a proof of concept to show that, hey, what we're trying to build with Spring is actually feasible and works. It's then since been revamped and updated and maintained as part of a first-class citizen when it comes to their repositories and their offerings. So I'm going to use it here to kind of show how it works. I'll walk through the app a little bit when we get it deployed, but it's not really the focus of this. It's just more of an artifact on the internet that we can deploy. But we'll be using it today. All right, so if I try and end this show. All right. So here I have IntelliJ, and I have Spring Pet Clinic here to install. And I just pulled this from their repo. It's pretty straightforward. The only thing I did is I made a steps.markdown, so I remember all my steps I have to do. So hopefully we can walk through these steps together, we can show how it works, and get going. So the first things first, let's log into Cloud Foundry. Here's my command right here. I'm going to point to the API at run.pivotal.io, and I'm going to use my student.cloudtraining.io username. It's going to connect me to it, let me run my password, authenticate me, get me in, and then automatically drop me into the cloudtraining.io org in the development space. If I export cf trace equals true, and then rerun that, you can see this thing's super chatty, right? So if you're ever having CLI problems, feel free to turn on cf trace and they'll log all the logs for you. But I'm going to turn that off because, oh my god, it's so much talking. Awesome. Cool. So first things first, I have to build my artifact. So let's just copy it. I'm going to clean it and package it. It's going to run all the tests, make sure everything works. Here's hoping that the internet holds up for us, because now I'm going to download dependencies, and that's always the fun part of demos. I'm using a real cloud and real downloads, and I'm terrified if it doesn't work. Cross your fingers there, everyone. It's going, it's going, it's going, it's going. I probably could have skipped the test too. But if you guys want some quality code, I want to make sure that you guys got it. So cool, let's do a CF push, right? So if I do a CF push, and I can just define the application that I want to build or deploy, so I'm going to, that's not what I'm doing. So CF push, I'm going to push my application name, Pet Clinic CCC. The path to the deployable artifact is the snapshot jar, which I'm just going to run. So you can see here that it kind of built itself a small mini manifest, but it's saying, okay, I'll deploy an app with this name, and I'm just going to auto-bind this route to it for you. If I didn't want that, I can do I can define no route. Just say just push my app. It's also going to start the app, which I can also define. I could define no start if I want to just kind of deploy it, get everything staged, and then click the switch when I'm ready. So what you see it doing now is it uploaded the artifacts, right? Uploaded the jar up. It's going to store that in the cloud controller. Down here, it's starting to look at all of the build packs and figuring out what's the build pack that matches, right? So it is walking in its automated order. It figured out that I should use the Java build pack. And then now what it's really doing is building that droplet, that executable file that it's going to store in its
If
database.
if there are multiple Java versions, how do you?
So it goes in order, top down. First one runs it. So if I run CF build packs, it'll show you the build pack. I'll do that. I'll run CF build packs. It'll show you the build packs that are installed, and then the execution order you'll see too. So if I do CF build packs. Right. So the first thing it checks is the static file build pack, and then you can see the second one here is a Java build pack that they have here. And then if you keep going down, they might have more. There's another Java one. It'll check 11. And that's it. So yeah, it would go in order, right? Top down, 1 to 2 to 3. What's that?
So what's the point of the whole build pack idea? I mean, obviously we know this is a Spring Java app.
Mhm.
Why bother making it search for everything under the sun?
It's just trying to kind of in an automated way. Yeah, like I don't think it knows that I uploaded the Java until it actually runs a Java app, a jar, until it runs the staging part. And that's really what I'm trying to say, what's the best fit for it. And part of that, like some of the build pack API, is there's a function that says, am I the build pack for this type of executable? So I think it's just trying to take like an agnostic approach to it and saying, I don't know what's going on or what the file is, and I'm just going to ask each build pack if it knows how to deploy it.
You already built, right? You already built outside.
So I've compiled it, right? And
Compile it. You already got jar now. Just put it in the server. Why do you need all these build packs again?
because what it's really trying to do is build that server environment, right? Again, if I'm going to deploy a jar, I need Java installed, right? So what it's really saying is I have a build pack that has Java installed. You've deployed a jar. I know these things go together. So let me build you a droplet, which is the server environment that I'm going to restart.
Who is going to decide the build pack, like JDK something version and all?
Sure. So the Pivotal team release official build packs as part of their release schedules. They do this they do like some of the security vulnerability. They're constantly pushing new build packs that kind of resolve those issues. Your company yourselves could push your own build pack. So maybe I take the Java build pack.
Download that one.
Pardon?
What if it can't download? Now it's downloading all the required build packs based on the API, right? So now in the middle, like I got an error, like.
Then it will fail.
It said,
Then your deployment will fail.
what is the next step?
I don't know, run it again.
No, it's not.
Turn it off and back on?
Keep on saying like you can't download. What is the alternative step like? I can.
What I would do is I would reach out to your Cloud Foundry support team, or really look at the configured build packs you have in your, because these build packs are pre-configured on the platform, right? They're backed by a GitHub, they're built and stored on the platform. So if you have a bad build pack that's not working, then you should remove it from your platform, right? And then install a build pack that's working. Now, if you think there's like a network infrastructure in the middle, Cloud Foundry is a very complicated deployed set of services that there might be an issue with a particular
How do
service.
you remove that one?
Do the CF build packs command.
Can you remove a specific build pack which is not downloaded?
You can.
Minus C.
Yeah.
ESC, yes.
So there, create build pack, update build pack, rename, and delete build pack. So if you're having trouble with the build pack, you can remove it. Awesome, cool. So we deployed our app, and I feel like as if, okay, cool. So here we are. It's waiting for the app to start. You can see here, now it's here, and now my route's here, right? So if I go to Chrome, There's my application, Spring Pet Clinic. So a little walkthrough on this, it's pretty straightforward. List of vets that my pet clinic is aware about. Now this is doing database queries behind the scenes, just a little bit of an infrastructure. I can find owners, so I can find my owner here. These list the owners if I dig in deeper on any of them. I also have the list of pets that they have and some information there. And if they have to plug away, it's using H2 database, which is an in-memory database real quick that we can talk about. What's important to note here is that if I was to add a person and then restart my application, I'm going to lose my data, right? Because it's in memory. If I have 2 instances, I might have, I'm kind of running in a stateful way. So if you might get load balance to the first instance, your data gets added, you go to the second instance, it's gone now, right? So some limitation to this and some rules that we're breaking. But let's keep going, right? So we can take a look at the logs here. So if I look at the recent logs, this is going to give me the dump of the log buffer. So you can see here, this is what was here. You can see these are the query I just ran, last name where I didn't put one in. If you keep scrolling back, you'll see the startup logs. So you can see them there. If I just remove the recent, I can essentially just tail the logs, which I'm doing here. So nothing's happening on the server, but if I go to it and hit refresh, you can see here that I pulled in this information, and I can watch it live. So it has a kind of a standard login format. It's a timestamp, what kind of HTTP request it was, the endpoint it went to, the HTTP response code, the size of the response, things like that. So you can kind of look through there too. If you start seeing 500s or 404s, you know that something's kind of funky with your application. You can start tracing back what's going on there. You can always pipe this to whatever you want. So if you want to pipe that to grep and look for the word pet. Maybe that was a bad word to grab on. Right, now you can kind of filter that too. So again, however you like, whatever your needs are, you can do that here. Again, you could ideally set this up to fire hose towards some kind of a logging process, or that will keep long term, so you have a nice pretty UI and you can search that way. Because this will only be kept as long as I have it open. Cool, so we've deployed a basic application. That was pretty painless, right? I built my application, I've compiled it, I uploaded it, it mirrored it to a build pack, which gave it an environment to run the application in, and a quick one-star thing. I was able to see the logs and kind of follow it, and it's up there. So let's keep going. Let's start looking at a manifest, right? So what does it mean to build a manifest? And really it's, how do I take that configuration? So up here, I have manifest YAML, this one right here. That was the same one I showed earlier. So I've defined slightly different things. I'm using 1024 memory here, so that was different than the screenshot I had in the deck. But I went from 1 instance to 2 instances. So what I'm really saying is I need a little bit more availability. Maybe my application is very popular, and I need it to either for load or for redundancy, whatever it may be. So what I can do here is just go back over here, and actually let's log into Pivotal and take a look at our application here. And then we'll deploy it with the manifest and see the changes. Do you remember the password? Sometimes. All right, so here's my org, here's my space, here's my Spring. That's the only one running. It's been pushed 9 minutes ago. So up here, let's take a quick walk through here. You can see I have one application running. The memory and disk usage about it right here. I can terminate it if I'm really feeling cavalier, but we won't right now. And then some history on what's going on with the application. On the left-hand side, there's no services it's using, so it's just kind of floating out there in the ether. I don't have any custom scheduled tasks around it, things that I might want to have run off processes that run in the middle of the night or in the morning that my application might want to do. Here you can see my configuration settings. So it has the startup script that I used here, this command here. That's heavily based on the build pack. It gets identified there. I'm using port health checking, so it's just checking the port, making sure it's still up. Down here I can reveal my environment variables. So this is that VCAP and that application environment that gets injected at startup. I haven't applied any environment variables, but we'll see that after we push the manifest. I think we'll get a spring profile here, right? We'll put a dev one in there. And then down here, here's the logs if you want to tail the logs from here. This is the buffer snapshot, and if you could put, play here, you can watch it live as things are changing. And I only have one wrap onto it, right here. All right, cool. So let's push it with the manifest, right? So if I do cf push -f manifest.yaml, it's going to read in that manifest. It sees here that there's actually a change here. I've added an environment arg, and I've changed my instances from 1 to 2. Again, I'm going to go through the same process. I'm going to re-upload it. The bytes, it's going to store those. It's assuming that it changed. I'm going to rerun through the build pack selection process. It identified Java correctly, and now it's going to try and start out. Waiting for it to start. Ideally, we can watch all these logs up here if we'd like. There's your banner on the startup. You can watch it just as easy there as anywhere else. And you can. Some more UI-centric folks can also gain the log access. I just prefer to the logs. So we should see 2 applications started. If we flip over to our overview, refresh this UI. There it is. There's 2 now. So I have 2 applications running. If one was to fail, the other one would, the router would identify that and route it only over to the good one, and then try and bring that one back up. So again, it was down. I didn't do a blue-green deployment that time, so I had a small outage there for as long as it took to deploy the app. But the app is back up. I think I can add an owner. Alright, so if I go to my Find Owners tab, I can see that, oh, how come, where did they go? They weren't there. But if I refresh it, I got them there at the bottom, right? So again, I'm using the in-memory database with 2 instances. I have a risk that my data is not replicating across the 2 because I don't have data replication. So hope you get routed to the right instance of the application every time you make a request because that's where your data is. It's a great way to run an application in production, right? But let's maybe try and resolve that, right? What if we kind of went and created a MySQL backend? What if we created a database, put that database behind our application and bound to that? And that way we can be sure that this service is going to manage the data. My 2 applications can be redeployed, you can be rerouted. I'm removing that state from my application. So we can go to the marketplace and see what offerings we have there. So if I run just coff marketplace, it's going to list the things that are installed there. There's not a small amount of stuff you can use, everywhere from application management to databases to Redis to auto-scaling to things I don't even know what these things are. It's always a good place to just want to learn. The one I want to choose is ClearDB because it's a highly available MySQL. So let's try and build one of those. So it's straightforward here. Right, define the service that you want, the service tier, and then the name of the service you want to create it with, and then any custom configuration. So a lot of times you can custom configure your database if you need a particular size or a particular access protocol or something like that. You can configure here. What we'll be running is not that. Is this command. I want to create a service. I'm going to use a ClearDB service. Right, that was the MySQL one. I want to use the Spark tier because it's the free tier. I don't have any money yet because my app isn't making me money. And then I'm just going to call it MySQL service, right? So if I just run this is going to interact with the Open Service Broker API and create this instance, right? So this is not hosted by Pivotal. This is actually hosted by another company who has this offering on there. So you can see it there. If I do CF services, it'll check my space for the services I've installed. Here I am right here with MySQL service, and it's created already. So So it's actually quite fast. So that's pretty nice. I do have to make some small configuration changes to my application. I needed just to update some configuration and really tell it to run in a MySQL mode. And then I also need to tell the manifest file to bind to the service on deployment. So again, I'm saying that my app is a database. I'm using my configuration to tell which configuration to bind to. So if I go to my manifest, I just have to change it to MySQL, and we're good to go there. Little underline note here. It is never that easy to do this, as Josh said earlier. Just note that I do have the MySQL runtime jar running here, right? So instead of using H2 database as my runtime, I'm now switching it over to MySQL. So my app still has the dependencies it needs, right? I'm deploying it with dependencies it needs. I'm telling it that it needs MySQL now, and then it'll be enabled when I bind to MySQL. So if I now deploy my application, I didn't bind the service, whoopsies. I need to tell it about the database. So bind it to my database, and I set my profile to MySQL, and I'll re-upload here. And we should be able to see this now change as it sees that it now has a service dependency, and then the environment configuration changed. And hope you're not saying about an hour. Okay. It does get redundant down in the build pack, so we'll run over to the gentleman in the back. I agree.
So these are both running in Docker containers, right?
So they're not running in Docker. So you can push Docker containers up to Cloud Foundry. What we're running is what they call Diego cells, which are managed by the Cloud Foundry platform themselves. And these are the containers that are actually, those are the containers that are actually running. It's just running these one-off processes within them. So there's actually no Docker involved here, but it does support Docker. So you could go to like a Docker hub, download a database, and then push it back up, right? Deploy it right there. So my application's up and running now. I just take one is up. We can see here that it's now bound to a service, right? My clear DB. If we look at my configuration under setting, I can go down here. See that I'm running in that MySQL profile, right? Again, if I wanted to manage this through JSON, I can reveal the environment args. Down here it gets very interesting, right? You can see that I have this vcap services. I'm binding to ClearDB. Down here it has my JDBC URL, right? So I'm connecting to it through a URL. So if they were to migrate it or change it under the hood, I don't really care, as long as their network routing stuff, logic works. There's my username and password. Close your eyes. And then again, the configurations that I've defined. First of all, some of the configurations that Cloud Foundry defined, but also the configs that I've defined are in there as well. So if I go to my application now, hello world is gone for good. Better read, yeah, it's gone for good. We're now going to a real MySQL database. So if I should be able to add someone back in. Hello world. This has to be a number, or else the validation will give me. I don't know how many times you want me to refresh the page, but they shouldn't go away. Yeah, how do you do that testing, right? Test until they are not found. Anyway, so now they're here, right? I'm sure I've load balanced between my instances. But now I pulled that state out, I put it in my database. It was relatively straightforward. But I'm sure there's some other stuff that we can enhance here. I know there is because I made a list of them. Cool, so we've made that. We pushed using our manifest and defined it there. Why don't we use the blue-green deployment, right? Every time we deploy, we do create an outage. So why don't we try and resolve that? So I was looking at the blue-green deploy plugin in Cloud Foundry. So if we ran that repo plugins, right? Here's all the list of all the plugins. And some of these are like kind of straightforward and fun to use, and some are just like really interesting. Like some of these are like, will it connect? Like just fundamentally, can my Cloud Foundry connect to a URL? Okay, that's good to know, especially if you're in like a complicated network environment with a lot of firewalls and whatnot. There's one that downloads the droplet, so you can like run it locally or whatever you might need to do there. The one we're looking at is the blue-green, right? How do I run a blue-green deployment? So CF blue-green deploy -H. Oh, that's how to use it, right? So I can kind of define my app name. If I have a smoke test script, I can write a script here to make sure that it works before it does the route cutover, or the manifest, and then delete old ass will just aggressively delete the old version if I wanted to. So really all I have to do is say blue-green deploy -F manifest.yaml. And let's watch this logging as it comes out because it's really interesting. Yep. Yield app name. What do I call it? Pet clinic CCC, something like that. Space -F. Yeah, there it goes. So it creates a new app called new, right? Creates a new route against it, which is the name -new, right? Binds it to your application and then waits for your app to start. I didn't specify a smoke test script. What it would do then is run the smoke test to make sure it works based on that script. This script is very straightforward. It gives you as the first argument the URL that it's using for the temporary application, and as long as it doesn't exit 0, you're good to go. Or as long as it does exit 0, I should say, you're good to go. Same process is running. It's trying to deploy. If we go back to our application instance here, not application instance. Yeah, I don't want to say this. If I go back to my space here, I see that my app is running here just fine. It crashed, which I don't think is true. It's just starting still. Yeah, it's still starting, so I don't know why, of course, it doesn't crash. But you can see my current application is totally fine. My new application is still starting. Again, there's no outage here. I can continue to click refresh here and see what's going on with no fear. Click, because that way I'm focusing on my code and not deploying code. They gave me 90 minutes, so that's why I wanted to build my app 30 times. Take up some time. Delete. All right. So now it's doing all the heavy lifting. If I go back to my development space, there it is, cool. So now it's up. And you can see here I've got a whole new Spring Boot section there on the left. Right here on the left-hand side, there's this nice green Spring Boot logo. So what this really means is what I can do is I can kind of check out and see what's going on. I can do network tracing. There's just no network access, that would make sense. Right, so I can see, hey, I got a 500. My owner's not fine. I can see some of that information here. That's able to pull by itself. I can do a thread check. I can see what's going on here. I can even dump them if I need to. So now I have this visibility into what's going on in my application. One of my favorite features, if I go over to the log side, sure, it's great that I can see my logs, but now I can, in the moment, configure logging levels across the board. So it was one thing, okay, we'll change your logging level to debug and restart the app. Now I can just kind of do it on the fly. So I got a lot of these features for free, and it's really cool. If I go back to some of the logs, you'll see that it's a lot more chatty now. As Cloud Foundry is now kind of checking my application a little more aggressively. And I guess not today. Usually you see a bunch of like Cloud Foundry checking, things like that. So that was just some freebies that I got from Actuator. Things that we've always used for Actuator was doing health checks. Right? Status up. Alright, so this might be some automated processes that you're running. What this will do is it'll run through the health indicator set that's deployed with your application. So I'm talking to a MySQL, so it'll probably check MySQL. Can I connect to you? Are you working? It does disk space checks, things like that, out of the box. I can look at my environment variables from up here. Yeah, right, easy to read. Just JSON, and I don't have like a nice pretty JSON plugin on right now. But you can now see the environment variables. It tells you what the config files know it's about, where it read it from, things like that. Yeah, what's up?
I'm sorry, the network tracing section, I'm just curious if that's integrated into the observability framework, Zipkin, or Foundry?
I don't think so. I'll follow up with you. All right. Yeah, it looks like noise. It tells you what the environment arcs it came from, where it got that from. Did it come from the VCAP services? Did it come from an application.yaml? Was it a custom configuration on the environment arcs? Like when you clean it up, it's so nice to read it. Alright, so your port, my space names, where I am deployed. It's smart enough to not show you my passwords. Gotta work on that, team. Except here, so it's not to be improved. But some of these you don't want on in production, right? Some of them are super helpful in debugging. For example, you can see your bean stack now, right? So you can see all the beans. And I'll tell you, this is your bean I've created, it depends on this bean, it depends on that bean. So a lot of freedom you get from Actuator, which is highly recommended, but really the idea is look at how it integrates with Cloud Foundry and some of the perks you get out there for free. One of my favorite endpoints on it is the shutdown endpoint that it exposes. So now what we can do is we can shut our application down. So if I take a look at Cloud Foundry here, you can see there's 2 instances running. What I can do here is go to manage/shutdown. It's not a git. All right, sure. curl-x post to that, and I'll pick the JQ so we have some great colors. And then we're going to shut one instance down. So I just told one of the instances to shut down, which means that hopefully Cloud Foundry here opens its eyes. It's seeing that the instance 0 is no longer responding on its app health. It should consider that it crashed and then try to restart it. And there it goes, right? You realize that it crashed and it auto restarts there. So if I run it again, I'm going to have 2 crashed apps because I have 2 instances. And now I have nothing bound, right? So Cloud Foundry knows it's supposed to be there. It's just unfortunately both instances are down. But you can see there it does an auto checking. It sees the instance is down and it'll bring it back up. In this case, I might have 2 instances in production, at least 2 for kind of some reliability. I might scale it up if someone keeps calling the /shutdown endpoint, or I can just turn it off. Might be a wise move too. And it's actually easy to do that considering I had to turn it on for the demo here, so I have to set default. So I walked through, let's see, and then we talked about that. The application should come back, let's show that, and it's back, right? No worries there. So we flip back over to where we were here. Here's the things that we kind of walked through. We ran through CF push. How do we push an application? CF push with manifest, right? We were able to move that configuration to a manifest file. We created a MySQL database. We then bound it through our manifest to our application. We were able to run a blue-green deployment, moving us from a deployment that caused downtime to a deployment that did not cause downtime. We then enabled Actuator and saw the freebies that we got from Cloud Foundry and how to interact with our applications. We were able to demo application auto restarts by how shutting down my application led to Cloud Foundry recognizing it and bringing it back up. So when I'm sleeping at 2 a.m., I can keep sleeping. And then finally, we were able to view our logs and see what's going on in my application instances. So that's all I have for you today. I hope you all got some information on how to use Cloud Foundry, some of the features that are brought, but also some of the ease of use that you guys can employ yourself. I'll hang out up front here, but if you have any questions, come on up.